In this video, we're going to talk about tributary areas and how the forces of a large load are distributed and loaded onto its supporting structures. Take for example this bridge. The bridge is supported by 3 concrete beams that run along the length of the bridge. The beams in turn are supported by a series of vertical slabs that raise the bridge off the ground. If there are many support structures or the load is not symmetrical, then the load distribution varies. It's important to know how the load is distributed and what load is borne by what support. Let's consider this large concrete slab that is 10 meters long, 5 meters wide, and 0.2 meters thick. The density of the concrete is 2,400 kilograms per meter cubed. The weight of the slab can be found by calculating the mass of the slab, which in turn is found by multiplying the density of the concrete with the volume of the slab, then multiplying the mass with the acceleration due to gravity, which is 9.8 meters per second squared. If you're unsure about how to do this, take a look at the introduction to loads video. So for this slab, its weight is 235,200 newtons, or rounded to 235 kilonewtons. Now, if this slab was supported by a single beam running along the length of the slab at its center, then the beam would be supporting the entire slab on its own and would have a load of 235 kilonewtons on it. If the slab was instead supported by 2 beams along its edge, then each beam would be carrying half the load of the slab, or 117.5 kilonewtons each. So what if the slab was supported by 3 beams evenly distributed along its length? Would each beam be loaded with a third of the weight of the slab? It turns out not to be the case, but we can work out the load on each beam by calculating its tributary area, or the area of the slab that each beam supports. To work out the tributary area for each beam, let's look at the slab from the plan or top view. So here we're looking down onto the slab from above. The 3 beams underneath the slab are shown as the dotted rectangles in the view. A tributary area for a support element is an area that is bounded by the boundary that is halfway to the next support element. So let's start with the top beam. We notice that the top beam runs along the top edge of the slab. The beam next to it is a middle beam, which runs along the middle of the slab. Since the slab is 5 meters wide, then the middle beam is located 2.5 meters away from the top beam. So the distance halfway between the top beam and the middle beam is 1.25 meters from the top of the slab. The tributary area for the top beam is thus the area of the slab from the top down to 1.25 meters. We can now work out what the load on the top beam is by calculating the weight of the concrete in that area. The mass of the slab on beam 1 is thus the density of the concrete, which is 2,400 kilograms per meter cubed, times the tributary area, which is 10 meters times 1.25 meters, times the thickness of the slab, which is 0.2 meters. The weight is then the mass times gravity, which is 9.8 meters per second squared. So this gives us a weight of 58.8 kilonewtons. This is how much load is on beam 1. Now the tributary area for the center beam is determined in the same way. It's the area halfway between the adjacent support beams. So it extends from where the top tributary area ends to halfway down from the center of the slab to the bottom of the slab. So the width of this tributary area is 2.5 meters. The width of the center tributary area is twice the width of the top tributary area, which means that the area of the slab is twice as large, which means the weight of the slab is also twice as large. So the weight that is supported by the center beam will be twice as large as that of the top beam, or 117.6 kilonewtons. So the bottom beam must support the remaining slab area, and by symmetry, the bottom beam supports the same area of slab as the top beam. So it would carry the same load of 58.8 kilonewtons. Now if we added up all of the loads that are carried by each beam, that would add to 235.2 kilonewtons, which is exactly the total weight of the concrete slab. So we can see here that the weight of the slab is not evenly distributed amongst the 3 supporting beams. The center beam supports more weight than the outer beams. Twice as much load actually. In order for the 3 beams to support the slab equally, their tributary areas will have to be equal. So the slab would have to be split into 3 equal parts, like shown here. The slabs would then have to be placed such that the area boundaries are halfway between adjacent beams, or in the middle of each tributary area. Beam 1 would have to be located at 0.83 meters from the top of the slab. Beam 2 would be located at the center, and beam 3 would be located 0.83 meters from the bottom of the slab. Let's have a look at another example. Consider a wooden dining table. Again, looking at the plan view of the table, e.g. from the top down. The mass of the table is 100 kilograms, so its weight is 9.8 kilonewtons, and is supported by 4 posts at each of its corners. How much weight is supported by each post? We can see intuitively that each post will support a quarter of the weight of the table, so 25 kilograms or 245 newtons. Let's see how tributary areas can provide an explanation to this. Let's first look at the top left post. To work out its tributary area, we need to define the boundaries halfway to adjacent posts. So the halfway point between the top left post and the bottom left post is here. And the halfway point between the top left post and the top right post is here. And the halfway point between the top left post and the bottom right post is here. These points define the corners of the tributary area for this post. For the bottom left post, its tributary area is defined by the boundary of the area of the top left post and halfway to the bottom right post, which is here. So its tributary area is the bottom left quadrant. Likewise, the tributary area of the top right post is defined by the boundary of the top left post down halfway to the bottom right post. So its tributary area is the top right quadrant. Finally, the bottom right post supports the rest of the table. From the analysis, we can see that each post does indeed support evenly 1/4 of the table. Let's add 2 more posts to the table as shown here and see what the tributary areas would look like for each post. Following the same analysis where we find the boundaries halfway between adjacent supports, we get the following tributary areas. So we can see here that the center posts carry more weight than the outer posts, just like the 3-beam problem that we did earlier. Of course, once you found the area, you need to calculate the load by calculating the volume of that area, and then multiplying that volume with density to get mass, and then multiplying that mass with gravity to get weight. In summary, a tributary area is an area of a loading structure that contributes to the load on a member that supports that area. It's useful for working out how loads are distributed onto multiple supporting elements.